In this example, we're given that the population of Detroit is decreasing at an average rate of 1.7% annually. Currently, the population is approximately 700,000. In Part A, we're asked to find the average rate of, or if the average rate of decrease continues, we're asked to find Detroit's population in 10 years from now. If we look at our original problem, there isn't any compounding here, so you could actually use a growth or decay model, or if you wanted to, you could go ahead and use your compounding interest formula, but the n would just be 1 there. So I think that would be just a little bit silly. We'll just go ahead and use this model. 700,000 is our initial P, and then 1, in this case it's decreasing, so we need to write a minus sign. 0.017, 1.7% is 0.017. And we're going to raise that to the 10th power, which would be our time. And again, if you did this with the compounding formula, this would be just divided by 1 and then times 1. So you could definitely do that, a little bit extra work, but not too much, not too much. We can go ahead and just type this in the calculator. So this is 700,000 times 1 minus 0.017, and that's being raised to the 10th power. And all we need to do is hit enter, and we're given our approximate value. Now this is decreasing, so just prior to this there would have been 589,703 people. And I would go ahead and round up in this case. We can't really have 0.8 or 0.8386 of a person, so we need to round up to 589,703 people. And again, that is just if the rate of decrease continues. That's what the population is expected to be. It's not saying that it will. Nobody can look into the future, but we can use math to predict what might happen in the future. So this is the answer for Part A. That would be the approximate population. B, how long will it take, assuming the current trend continues, for the population to reach 500,000. Let's fill in and fill what we know. And this time we don't know how long it's going to take. So we don't know T, but we do know A. A, the ending amount is 500,000 is equal to 700,000, and that is going to be 1 minus 0.017 and then to the T power. So there's a couple different ways to do this. Let me give you, move this up a little bit. Let me give you method 1. And method 1 is the good old guess and check. If we look at the previous example, if we were at 10 years, we still haven't made it down to 500,000. So you can just go ahead and check a few things in your solution here. And if you just used this, then you can go ahead and just type in second and then enter, and that will give you your previous entry. And so we can just go ahead and try some stuff. So let's try 15. Maybe in 15 years it might be down to 500,000. Nope, not in 15 years. And we can go second entry again, and we can change our time. We're just kind of guessing now. How about 20? About 20 years. Will it make it below 500,000? In this case it does. But we've gone a little too far. So if we do second enter again, we can come back and make this maybe a 19. So you can just keep guessing and keep checking. And then 19 would give us a little bit more, and then 20 would give us a little bit less. So sometime we could say between 19 and 20 years, so maybe 19 to 20 years, approximately, somewhere in there. That's when the population will hit 500,000. So method 1 is just guess and check. Just plug in different values for T. Use your knowledge from the past. We've got 10 years did not get us down to 500,000, and see if you can figure it out. There's another way that we can do this, and this is method 2. There's actually a third one that we'll talk about in a later example, but for now we don't know much about logarithms. So in method 2, we can graph this thing, and we can see where the value of y hits 500,000. So here's what we're going to graph. We're going to graph y is equal to 700,000 times 1 minus 0.017. And then this will be x up here. So x is going to be the same as time. We just have to use the variables that are in our calculator. So if we go to y equals, we can type in 700,000, and then we could type in 1 minus 0.017, and raise that to the x power. One of the things that you can do is just go right to zoom 6 here, and if we go right to zoom 6, we'll wait for the calculator here to catch up a little bit, but I don't think it's going to graph much. Yeah, it doesn't graph anything. So if you do use this method, you have to pick a good viewing window, and to choose a good viewing window, we know that we're going to be somewhere ish by 10 from 0 and then maybe to 20 or 30 or 40 for the value of x. So for the x window, for the x min, we're going to pick 0, and for the x max, you can change this if you need to, but let's just guess. We know that 50 probably will get us below 500,000. Also for our y min, so this is our viewing window here. So we'll do this in the window settings. The y min, we can do the y min at maybe 0 if you wanted to, or we really only have to go all the way down to 500,000. But if we make it 0, then we can see everything that's going on with this function. And the y max, we want to go a little bit above the maximum amount, and the graph will never, or what we care about, will never be above 700,000 because we're going lower than that. So we're going to make that 800,000. So to get that into your calculator, just go to Window, and we're going to go to the x min. That's going to be 0. X max is 50. And if you change your x scale to, let's say, 10, then there will only be 5 tick marks. If you don't change it to 10, there's going to be 50 tick marks if it was at 1. And for the y min, we're going to go 0. For the y max, we said 800,000. Now the same thing applies for the y scale. If you make the y scale 1, there's going to be 800,000 tick marks on the y axis, and we really don't need that. Let's just make those each tick mark 100,000. So there'll only be 8 of them. Let's see what happens now. The resolution's fine. Let's see when we graph this thing what it looks like. So if you pick a really good viewing window, remember each tick mark here is 1,000 and each tick mark here is going to be 10. We can get a really good clue, a really good picture as to what's happening with this graph. If we hit trace, we're right in the middle of the graph right now, and you can see the y value is at 455,969. And so we're going to move to the left to go to increase y, and again here we're looking for 500,000. So right about there, 19.68 for the x. We're getting close. There's 500,000 there, so 19.14. So we're definitely somewhere in the middle, probably closer to 19.68, so maybe 19.5, somewhere in there. This says round your answer to the nearest year though, and so you can see graphically that the value of x that produces a value of y close to 500,000 is somewhere between 19 and 20. So our answer here for method 1 is confirmed. We can get a little bit closer, you know, if we zoomed in a little bit. We could do that. We could use a table right around 19.68. And then in a future lesson, I'll teach you how to find a more precise value using logarithms. But that'll be for later time. And anyways, method 1 or method 2, graphing or guess and check, you can find the answer to be somewhere between 19 and 20 years.